Okay, on with the special senses. Uh, so this is part 4 of that peripheral nervous system lecture. We'll do smell happens in the olfactory organs, taste in the taste buds, hearing and equilibrium in the ears, and sight in the eyes. Olfactory receptors. These are chemoreceptors, and they respond to chemicals that are in aqueous form, so they have to be dissolved in some liquid. The olfactory organ has the olfactory receptors, and these receptors cover parts of the nasal cavity, superior nasal conchae, and a portion of the septum. So the septum where they're divided. Olfactory organs are located high in the nasal cavity, so they're way up there. And that's so that, like, little kids when they pick their noses really don't do a lot of damage. I mean, that's a big reason. But also that if we want to bring in a chemical and really pull it in and see what it is, rather than just say something that we're going to adapt to, we pull it up high in the nasal cavity. That's like taking that big whiff. And the olfactory receptors are so high, they're actually above where the normal pathway for inhaled air. They undergo sensory adaptation rapidly. So about a second or so after you smell something, your sense of smell for that particular chemical drops by about 50%. Okay, so those are olfactory receptors. Sense of taste. Taste buds are the organ of taste. So they're located on the papillae of the tongue, so where those little bumps are, the roof of the mouth, lining of your cheeks, and the walls of your pharynx. Taste cells, the actual cells in the taste bud, are modified epithelial cells, and those cells function as the receptors. And then you've got taste hairs, which are not shown in this picture, but the taste hairs are microvilli that protrude from those taste cells, and it's really, that's where the sense happens, on those microvilli. Those are the sensitive parts of it. So think of like really small cilia. There's 4 primary taste sensations. There's sweet. So sweet happens here on the tip of the tongue. Change. Make it green. There's sour. Sour generally happens here in the middle, not that far back. Bitter is back here. Bitter's back here. And then, salty are on the sides. So salty. We said sour's here and bitter's back here. So in general, sweet is carbohydrates, sugars. Sour is acids, salty salts. And then bitter is a lot of organic compounds. And the reason why bitter is way back here, and think about 200,000 years ago on the plains of the Serengeti, if you eat something and it's bad, it's probably going to get picked up by the bitter um, taste receptors, and that's kind of like your last stop before you swallow it. And maybe you shouldn't be swallowing that, you know, gazelle bone marrow that's been there for a week, and it'll make you spit it out or throw it up. Um, what else? I guess that's it for that. Oh wait, no. The other one is that spicy foods activate pain receptors. I think that's, I don't know why I even have to say that one. Okay, onto the ear. So the ear is, we've got this external ear called the auricle. And another name for that is the pinna. Oh, it stayed green. External auditory meatus is also the external acoustic meatus instead of auditory. And it's this pathway. And this one, remember, is lined with those ceruminous glands that are producing the earwax. It carries sound all the way to the tympanic membrane. Tympanic membrane is the eardrum. So remember for the test, though, you use the scientific word, not eardrum. You use tympanic membrane. And the tympanic membrane is what vibrates in response to those sound waves. It literally like a drum. So that's the external ear. And there you go. Middle ear starts with the tympanic membrane and has the tympanic cavity. Now the tympanic cavity is just an air-filled space in the temporal bone. Sometimes we get ear infections behind here, and then people have to get, if they have ear infections a lot, get tubes into the tympanic membrane to allow those to drain. Also in the middle ear, you have the auditory ossicles. We'll see more about those, but those are the tiny little bones in the ear, malleus, incus, and stapes. And then they've got the last part, the oval window is just under the stapes, and that's the where the stapes vibrates against the oval window to move the sound waves into the inner ear. So there's those bones. The malleus is the hammer. The incus is the anvil. Here are we? Anvil right here. And the stapes is the stirrup, because the stapes looks like a stirrup. And this one, the hammer, hits the anvil. The auditory tube is also called the eustachian tube. Okay, the auditory tube is also called the eustachian tube. It connects the middle ear with the pharynx, so the middle ear to the throat. And this is what equalizes that pressure on both sides of the tympanic membrane. It's usually closed. There's flaps in the throat that usually close that off, but it maintains that equal pressure. So, and this is what happens when you are driving, say up a mountain or down a mountain, or you're in an airplane and you're going up, and your ears start to hurt and then they pop. That's the equalizing of pressure, because let's say you're going up a mountain. What happens is the pressure out here gets lower, but the pressure in here stays where it was. So it's higher pressure, and that can cause pain. But eventually, if you open those flaps up, and this is why they tell you to chew gum or talk. I never tell people to talk on the plane. I just give them gum. But that's what you would do. And then those flaps open up, and then the pressure can equalize. Some of this pressure can escape. The inner ear has, the inner ear is this really complex system of labyrinths. And we only really touch the surface of this, but there's the osseous labyrinth, which is the bony one, and the membranous labyrinth, which is the tube, the membranous tube within the osseous labyrinth. The osseous labyrinth is filled with perilymph, this stuff right here. The membranous labyrinth is filled with endolymph. All right, the cochlea. This is the three parts of the inner ear. The cochlea functions in hearing. So this whole thing right here, that's the cochlea, functions in hearing. Semicircular canals function in equilibrium. There's 3 semicircular canals, and they lie at the 3 planes. And these function in equilibrium. And the vestibule functions in equilibrium. Okay, the cochlea, scala vestibuli, is the upper compartment. It leads from the oval window all the way to the end of the spiral. So all the way to the end of that cochlea. It's part of the bony labyrinth. Scala tympani is the lower compartment. So vestibuli is up here, tympani is down here. And the lower compartment extends from the apex, so way over here, all the way back to the round window is the scala tympani. It's also part of the bony labyrinth. So vestibuli is up here, this big long tube, and then you make this corner here, and the tympani is the compartment on the way back. Cochlear duct is the portion of the membranous labyrinth in the cochlea. Vestibular membrane is what separates that cochlea here from the scala vestibuli. And the basilar membrane separates the cochlear duct from the scala tympani. This is a really good picture for that. All right, organ of Corti is where all these little hair cells that pick up the different sound waves that come into the ear. Okay, they're on the surface of the basilar membrane. So here's that basilar membrane. Actually, this is a better picture down here. And here are those basilar membrane, and here are those hair cells on the organ of Corti. A different frequency will stimulate different areas of the basilar membrane, and that's how we tell different frequencies from each other. And then nerve impulses get generated based on where they are. And that's just kind of a cool picture. I mean, relatively cool. If you take all the organ of Corti pictures out there, that's probably one of the cooler ones. This is a good table for how sound sensory impulses are generated within that ear. And this table is on page 464. It's table 12.4, page 464. So in general, these sound waves come into the external acoustic meatus. And as they come in there, they get directed towards that tympanic membrane. The tympanic membrane vibrates, which vibrates against the malleus. The malleus vibrates then against the anvil, and the anvil vibrates against the stapes. So the stapes transmits the signal through the oval window, and they go into that perilymph and that scala vestibuli. You might have to look at the other picture, or the picture in the book when you're doing this. Okay. Eventually, as those get transmitted through there, through the scala vestibuli. They're going to pass through the vestibular membrane at some point, and they're going to vibrate against that basilar membrane, and that is what stimulates the organ of Corti. Okay, and then the neurotransmitter, you can skip these two. Skip 7 and 8. The sensory neurons then send a signal through the cochlear branch of the vestibulocochlear nerve. Remember which cranial nerve that is? And then it goes to the auditory cortex in the brain, specifically the temporal lobe. Equilibrium happens, static equilibrium happens on the vestibule. And this is when we're sensing our position in space when our head's not moving around. Dynamic equilibrium happens in the semicircular canals, and it senses that rotation of the head or the movement of the body. Okay. And these are the parts of the vestibule. Okay. Macula is going to respond to changes in the head position. So when you move your head forward, those hair cells are bent, and then that tells your body or tells your brain that, hey, our head's moving forward. Semicircular canals, or like we said before, they're all at right angles to each other. The crista ampullaris is what senses that something is, that we get a rapid turning of the head or rapid movement of the head. And then this crista ampullaris is something that as we get older and get out of our teenage years into our 20s, those hair cells start to stiffen a little bit, which is why older people can't go on roller coasters as much, because it's actually kind of makes them sick because of the sensations, because they're not picking up the sensations fast enough. All right, stop here.